Welcome back to part 2 of our series where we are beginning the monstrous task of parsing XBRL documents that are contained within SEC filing directories. So in our previous video, we gave some context as to, hey, what the heck are these things and how do we use them? So now that we have our context, we understand the information that is inside these documents and we understand kind of how they're all related together and ultimately why they were created and their purpose, we can begin the process of parsing it. So the parsing, it might be a little bit deceiving at first because initially you say, oh, that doesn't look too bad. It took a long time to get it to that point. It was a lot of experimenting, but eventually I was able to get it. So we are going to be using a couple of libraries inside of our wonderful video. And so the first one that we are going to be doing is we're going to be writing all of our information to a CSV file. So we are going to be using the CSV module. And then additionally, I can't remember exactly if I'm going to be doing it, but I'm going to actually be printing out some of the content. I want it to be in a readable format that's somewhat pretty. And so we're going to be using PrettyPrint. This is a library that you probably do not have installed. It's simply pip install PrettyPrint. And so it should be good to go. And then also you can also look online. I mean, it's pretty much all, it's a pretty popular one, so it shouldn't be too bad. Additionally, we are going to be using a standard library called pathlib. So this is actually a new library I started working with and pretty advantageous. I like it a lot, actually, especially when it comes to building paths and making sure that they work both on Windows and on Mac. Because I've been working with some clients who some are on Mac, some are on Windows, and that's been a whole fun experience for me, trying to make sure it always works. Additionally, we are going to be using collections. This is because we are going to be using named tuples. There's really no reason to use a named tuple, but I thought it was kind of just a nice way to add in some variety. I'm not sure if anyone's really used them, but they're pretty nice. I actually like them a lot, and I like them. And then from here, we're going to actually use a new parsing library. So normally I do everything with Beautiful Soup, but there actually is a standard library inside of Python called XML. And so with the XML library, there is actually an element parser. And so this is really advantageous because basically you can do all the parsing that you normally do with Beautiful Soup with a Python standard library. So that means in every installation of Python, you will have access to this library. So I thought it might be advantageous to maybe, just for the time being, show you an alternative. I personally liked it. I didn't think it was that bad. It's a little bit different than Beautiful Soup, but it works. I think it's pretty flexible, and I haven't run into too many issues with it, but I thought it was nice. Wonderful IntelliSense. Okay, and then from here, we need to define our working directory. So this is basically just going to make sure that it's a little bit dynamic and that it's going to hopefully work nicely with all the stuff that we're going to be doing. So the first one that we're going to do is we're going to create a new variable. We're going to call it SEC directory. We're going to call our pathlib module. There is a path object. And inside that path object, there is a current working directory method. So this returns the current working directory. And if you don't believe me, you can just print it out. And if you look at it, you'll notice it should say, once it runs, oh my goodness, there it is. This is my current working directory. So now that we have that, we can now call the join path method, and I can actually pass through the name of the folder that I want to join. Now, in my case, all the data that I have is inside this folder called Facebook 10Q. So if I do Facebook 10Q, it will, and it's lower, it's uppercase. Okay, perfect. It will join it, and then we should be good to go. Now, the nice thing about this, and I don't know if it's going to show you on this one, sometimes it will say, what is it in front of it is, I think it's after you call the resolve method. I'll double check. Well, we'll see in a second. Regardless, we've now defined our working directory. Let's define our file paths, right? So define file paths to the documents. Okay, so we'll call this one file HTM. This will be the one that's basically our main 10Q HTM file that contains all the values. We'll take our SEC directory. We will again call the join path method. And this is where I am just going to copy some stuff because I don't want to risk the chance of potentially, what is the word? Misspelling it. So for the time being, just accept it for what it is. Okay. So basically all I do is I join each of the files. So this is the HTML calculation label and definition file. And then I call this resolve method. So this is kind of the neat thing I liked about this library was when you call that, it will actually resolve the file path and make sure that it's proper format for whatever system that you're on. So I like that a lot. So if you're on Mac, it will actually create a different one for you. Now I'm sure the OS library, I know the OS library can do it, but I don't know. To me, this one just seemed intuitive. I was like, oh, that didn't seem hard at all. It's actually pretty nice. So very good. We have our files. What are we going to do through now? Well, now comes the fun part. Ultimately, we're going to be parsing data. We need to store that data somewhere as we're looping through these documents. So we're going to basically define the different storage components. So define the different storage components. Okay, that's not too bad. Our first one is actually going to be a list. So one is just going to be a list, and this will house all of our mini dictionaries, as I call them. One will be storage values. So this will be values, and this one will be a dictionary. And then additionally, we are going to have something called storage gap. This will also be a dictionary as well. So for the time being, I have broken up how I store this data. I'm sure at some point I will find a way to merge it all together, but for the time being, just mentally in my head, I have to keep it separate because it's really easy to get lost in this as you're parsing it. So for right now, I think it's more advantageous to keep these two separate than trying to merge them when I really don't know what I'm merging. Okay, from here, let's create a named tuple. We've done this. Okay, so we'll call it a filing. We'll call it filing tuple. We'll go into our collections module and look, there's a named tuple. That's neat. We give it a name, so we'll just call it filing tuple. That's pretty cool. And then we can basically pass through a list of the different elements that we want to have names for. So in this case, I'm going to have a file path. I'll have another one called namespace root. Okay. And then additionally, I will have something called a namespace underscore label. Okay, not too bad. So from here, we can now basically make our quote unquote list of tuples that will contain our file path, and it's also going to contain the namespace. Now, for the time being, I am keeping this as a constant, but I do hope to have a way of identifying the actual namespace name. So right now, I create 3 filing tuples. Each one contains the documents that I'm going to be planning to parse. So right now, I'm just doing these 3 guys right here. I'm not even touching the HTML one yet. That's for down the road. For each tuple, I provide the file path, I provide the namespace root, and then the calculation. I'm sorry, the namespace label. This probably isn't the root. I think a better thing to probably call it would be element. So this is like the element that we're going to be parsing. And we'll see kind of why this is advantageous down the road. But from here, let's just, again, just to make sure things are kind of working and nothing's kind of broken. You can see that it is a name tuple. And oh, see, now it shows it. Regardless, now it shows that Windows path. So this is kind of the neat thing about it is that pathlib library. Again, it will make it a proper file URL, a file path, depending on the system that you're at. And then the nice thing about these name tuples is now we have these elements that we can easily access in our code. And instead of having an index with like 0, 1, or 2, I can give you some context as to like, hey, like at this point, like I'm going to be using the file path from the tuple or something like that. So I thought it was neat. Again, I'm sure you don't have to use it, but maybe you might. Okay, so now that we've done that, let's move on to the next portion. So for the, I'm trying to think what the best way to say this. For right now, to keep the parsing relatively simple, I define basically like 2 categories of labels, the ones I want and the ones I don't want. So here I define 2 categories of labels, those I want and those I don't want. So the reason behind this, again, there's just so much information in here. It's going to just take a while before I can kind of, I would say extract the pattern. But the ones I don't want are going to be called link-based. And then there's also going to be these other ones called role reference. These ones basically just don't contain anything that's useful to me, and I really don't care about parsing it. So I just put those in the I don't care, I don't want to see it. Additionally, we're going to have those that we want to parse. Well, I do want the label. I can tell you that right now. I do want the label link. That would be really nice. There's something called a label arc. This is, from what I've been able to tell, almost like I think it like kind of points you to the next element you're supposed to go to, I think. At least that's kind of the way I've been reading it, but I could be wrong. Additionally, I'm going to want a location element. That's pretty useful. Definition, I am definitely going to want the definition link. And then there's also going to be another one called definition arc. This is, again, it's almost like it's pointing you to somewhere else in the document. I guess that's the best way to say it. And then calculation arc. So again, it's just kind of like pointing you. Now, again, just because I'm paranoid and I feel like I will misspell this, as I already have, I'm just going to copy it. But again, at this point, we're just really defining two categories of labels, those I want and those I don't want. Okay, so now that we've done that, again, part of the parsing process is we're going to have to basically create our list of unique keys, and we're going to use that as a way to systematically organize our information. So what we're going to be doing is we're going to be using set, basically a set object, in order to house our information. Keep in mind, really the only reason I'm using a set is just more for efficiency process. So there's certain lookup benefit times that we get from using a set compared to a list. And so because of that, it's really advantageous to do that. And then on top of that, sets only allow for unique values. So I can be ensured that there are no duplicate values inside my sets. So create two sets to store my keys. Store my keys. Okay. We'll call this one lab_list. This will be short for label list. This will be a set. And then we're going to also have cal list. So this is short for calculation list. And then this one will also be a set. So from here, we can now begin looping through each file. So loop through each file. The fun part, right? So we're going to say for file in files list. What are we going to do? Well, the first thing we need to do is we need to parse that particular file. So parse the file. That's not too complicated, hopefully. Why is there a syntax error? It's probably because I didn't write anything. We'll call it tree, just for time being. So in convention is you kind of just call tree. We're going to call our element tree, basically this guy up here, our element tree object. And we're going to say parse. And then with this one, we're going to pass through our file tuple. And then we're going to call that file path label, basically, or that name, I guess, to be proper. And we're going to parse it. And then this is going to create this element tree. And from here, what we can do is we can grab all the namespace elements in the tree. Okay, so what we'll do, elements equals tree.findAll file namespace _ root. So just for the time being, let's just pause for a second. What the heck is this thing? What is this tree element? Sorry about that. I had to take a break for a second because initially I didn't think I knew what was going wrong. And then I realized that I was being foolish and I parsed it like that, which I shouldn't have done because that inherently creates an issue. Because when you do that, it doesn't return just the first element in that list. It actually returns the first element in the tuple. And so that was a problem because now all of a sudden, if you go here, this will actually return the tuple. So you can actually see the filing tuple that we want. And so if you now do this and do 0, you will see that it actually returns the first element in that tuple. So that was one of the Well, sometimes you just got to try things in life and see what happens, right? So one of the benefits, I guess, of using a different library. But anywho, all I really wanted to point out at this point was it's basically returning basically an element tree object, right? And this element tree object has different properties about it. So you can do things like, hey, get me the root element, right? So what's the root element for each of my documents? And it will tell you that. It will tell you each of the root elements, and you can go a little bit further if you want. You can say, hey, okay, I want to do a find all. I want to do a get iterator. I can do parse. And for the most part, it's actually not too many, but I think it's simple. I think that's what I've liked about it. It's just relatively simple, but I think sometimes like you're like, this is too simple. Like I'm used to like having so many more options, but I don't think you really need it. I think this actually does a pretty decent job of, what you're trying to do. But anywho, you have this element tree component, and now what we're going to do here is we're going to find all the elements that match our namespace root for each file, basically. And when you do this, it's going to return a lot. So just FYI, there's going to be a ton of information. Where is it? Did I miss? Oh, namespace element. Sorry, I misspelled it again. See, this is why I shouldn't read my notes. But basically what you see is that it's going to return back all the elements that match this particular namespace. So why is this the case? Well, if you go into the actual XBRL documents, you will actually see, so if I go to calculations, I will see as I scroll, I all of a sudden have these calculation link elements. So these are the ones that I want, right? So these are the ones. Now, even though here you're like, wait a minute, Alex, why didn't you do a find all like link : calculation link? It's because when it returns the element, as you kind of see up above, it actually returns the namespace as part of the element. And so it attaches the namespace into the actual element itself. We're going to see how to kind of circumvent that, but for the time being, it seems to perform pretty reliably. And I think for the most part, it does the job we need it to. We just kind of have to understand it's come back a little bit different, but nothing too crazy. So at this point, I'm just finding each element that I really care about in each document, right? So for labels, for calculations, it's the calculation link. For definition, if you scroll, it's definition links, and these can be nested, by the way, too. So these can actually be nested. And then it's going to be label. So we're going to have a label link in there as well. So those are really the ones I'm concerned about. I do not really care about the role ref and the link base. So those are why those ones were in the avoid one, because from what I can tell, these aren't telling me necessarily anything useful internally to this filing. It does point to some external sources if they're still available. They're not always available. But for at least the filing component, there's nothing really there that I'm caring about yet. So that might change down the road, but for right now, it's nothing crazy. But yeah, so at this point, we've gotten each element, so that's pretty good. So what we're going to do now is for each element, we're going to loop through them, right? So we're going to loop through each element. So loop through each element. So we're going to say for element in elements print. And then from here, we're going to create an iterator. So we're going to have an iterator that's going to loop basically through all the child elements if they do exist inside of that element. That's important because if you look at these, some have children, some do not. And if they don't, we're going to have to make our code a little bit more dynamic because we can't always be assured that what we're on is going to always have a child. So my solution was, well, let's just do an iterator and then see what's inside it. Because if there's only that element itself, it ain't going to return anything. So if the element has children, we want to parse those as well. And so we're going to say for child element in element dot iter. What are we going to do? Well, for right now, we're going to print that child element. And then I'm probably going to cut this video because I think we're getting close to the end. Yeah. No, don't take me to an external link, please. FY, there's going to be a lot. So you can kind of see it's going through each one of them and it's printing everything out. So might not seem like a lot, but trust me, there's a lot there. So at this point, we now know how to get all the elements that we care about from each document, and we know how to get all their children elements that we also care about. What we're going to do next in the next video is we're going to get the attributes. So we're going to get all the attributes regardless of what they are inside of the element. At least in this portion, we're going to do it. We're going to see with the HTM one, we're actually going to be a little bit more selective, but down the road, we'll make that basically more general too. But yeah, so at this point, we know how to get those elements in the children elements. In the next video, we're going to figure out how to get the actual, attributes from that particular element. So if you have any questions at this point, feel free to put them down in the comments below. Otherwise, we will see you in the next video.